This is a very interesting scenario we have here. Two cars moving at 40 km per hour and 30 km per hour towards each other are 150 km apart. The question wants us to determine when the cars will collide. What is the time it will take the cars to collide? And what distance would each car have traveled before they collide? Very interesting and simple. To start solving this problem, let us identify each of the cars. Let's call this one A and this one B. Driving towards each other means at some point along this 150-kilometer distance, the cars will come together and collide. Let's mark that point and call it a distance of x from the position of B, which means if they collide at this point, the distance from this point to the original position of B is x. The whole distance is 150 kilometers. What it tells us is that at the point of collision to the original position of A, the distance will be 150 minus x. So we can call the distance between A and the point of collision 150 minus x. If that is correct, we just need to find the value of x to determine the distance of B from the point of collision and the distance of A from the point of collision. Remember, it takes the same time for both of them to collide. Looking at the scenario, at that time both collide, we are looking for that time as well. So it takes the same time for both to collide. We need a simple equation of motion to solve this problem. And the equation says speed equals distance over time. V equals s over t. Remember that it takes the same time for both of them to collide. That time is common to both the time A traveled and the time B traveled. So because we're looking for the time, we need to make t subject of formula. If we make t subject of formula, we have that the time it takes to collide will be the distance divided by the speed. So for the first car A, the time it takes A to get to the point of collision is 150 minus x, the distance, divided by 40 km per hour, the speed. The time it takes B to collide is the distance x divided by the speed of B, 35. We just agreed now that it takes the same time for both of them to reach the point of collision. The reason this one looks longer is because this is traveling at a faster speed. So it's going to cover a larger distance before B gets to that point of collision. So since TA and TB are the same, we are free to equate them. So 150 minus x over 40 will be equal to x over 35. Now it is simple, it is easy to solve for x. By cross multiplication, 40 times s gives us 40x, while 35 times this gives us 35 into 150 minus x. Opening up this bracket, we have 40x plus 35x equals 5250, because 35 times 150 is 5250. 35 times negative x is negative x. When it crosses over, it becomes positive 35x. So 40x plus 35x is definitely 75x, and that's equal to 5250. To obtain x, we divide both sides by 75. That gives us x to be equal to 5250 divided by 75, and x equals 70 kilometers. What it means is that the car B is 70 kilometers from the point of collision, which means the car A will be 150 minus 70, which is 80 kilometers from the point of collision. So in terms of the distance the cars have traveled before they collide, we can conclude that B traveled 70 kilometers while A traveled 80 kilometers before collision. Now we know the distance. Let us look at when, the time. On the next page, we have all of this formula from the previous page. We know that TA is equal to TB. So if we just get the time T, the T becomes equal to the time for TA and TB. So I'm saying in essence that the time it takes on whenever they collide is equal to the time of A and is equal to the time of B. So we are going to just pick any of this equation, and I'm going to pick TB, which means the time will be equal to x over 35 where x is 70. 70 divided by 35 gives us 2. So it takes 2 hours for the cars to collide, and B would have traveled 70 kilometers while A would have traveled 80 kilometers. So you can see that the question is very simple but logical. Now that you've seen it's simple and you've understood how it is solved, I have a simple one for you as physics students or physics people that study physics or interested in physics, right? If both cars accelerated from rest uniformly to reach the given speeds, what is the acceleration of A and B? We know that the speed of A is 40, the speed of B is 35. We are now saying that if both A and B started from rest and accelerated uniformly before they got to 40 and 35, what is the acceleration of A and B? Please put your answer in the comment section, and thank you very much for watching this video. Hope to see you in our next video.